Hello everyone, my name is Mr. Zabron Ernest. I teach mathematics. Welcome back to chapter 5, prime time, class 6. Right? This is a quick review that I want to remind my students some few concepts. So there we go. The first question, a bicycle rental shop charges for ride in two ways. One ride takes 5 minutes and another takes 6 minutes. If both rides start at the same time, after how many minutes will they finish together again? So, this is a word problem, a real life context. But what is the concept? The concept, you need to find the smallest number that is a multiple of 5 and 6, and that is also known as LCM. So the concept, you need to find the smallest number that is a multiple of 5 and 6. The smallest number that is a multiple of these two numbers, in short, it is known as LCM of 5 and 6. Now, how do we find the LCM of 2 numbers, 3 numbers, 4 numbers, 5 numbers, and so on? How do we find the LCM? To find the smallest number that is a multiple of these two numbers, we use the method, we call it prime factorization. This prime factorization is simple. You keep the numbers here. In this case, I have two numbers. One number is 5, another number is 6. So you keep those two numbers, put them like this, and then you start dividing, starting with 2, if there is any number that is divisible by 2. Do we have any other number? We have only two numbers. One number is 5, another number is 6. Now, do we have any number among these which is divisible by 2? If yes, then you start with 2. So 5 divided by 2 is not possible. Copy paste 5. 6 divided by 2 is possible. That is 3. Can these two numbers be divisible by 2? No. So you go to 3. 5 divided by 3, not possible. Copy paste 5. 3 divided by 3 is 1. One more last step. This we have 5, so put 5 here. 5 divided by 5 is 1. And this is 1. These numbers you got here are the ones which we multiply. The moment we multiply these numbers, 2, 3, 5, 2 into 3 into 5, the answer you get will be the smallest number that is a multiple of both 5 and 6. So the smallest number, which is a multiple of both 5 and 6, it means find the LCM of 5 and 6. So LCM will be equal to, when you multiply these numbers you got here, 2 into 3 into 5. So 2 into 3 is 6, into 5, 30. So, according to this word problem, a bicycle rental shop charges for rides in two ways. One ride takes 5 minutes, another ride takes 6 minutes. If both rides start at the same time, after how many minutes will they finish together? So it will be after 30 minutes. So the concept behind this question was to find the smallest number that is a multiple of 5 and 6. That's all. That is the concept. The next question. Two buses leave a station at the same time. So 2 buses leave a station at the same time. One bus stops every 4 kilometers, while the other stops every 6 kilometers. Within the first 100 kilometers, at which distances will both buses stop together? Concept. Two buses leave a station at the same time. One bus stops every 4 kilometers, while the other stops every 6 kilometers. Within 100 kilometers, at which distances will both buses stop together? The concept here is this. You need to find common multiples, not the smallest common multiple, no. You need to find common multiples of 4 and 6 up to 100. I repeat this. You need to find common multiples of 4 and 6 within the first 100 numbers, because multiples of a number, they go to infinity. So according to this question, the limit up to where you should mention the multiples of these numbers, you should go up to 100, not more than that. Now, you need to find common multiples. So here, concept is you need to find common multiples of 4 and 6, but you should not exceed 100. So you need to find common multiples of 4 and 6 within the first 100 numbers. This is the concept of this question. Now, how do we find multiples of a number? Everybody pay attention. Multiples of 4 are, you start with the number itself, which is 4, and then keep adding 4, adding 4, adding 4, adding 4, adding 4, adding 4, until you hit 100. If 100 is part of the multiples, otherwise it should be less than 100. So keep adding 4, 4 plus 4, 8, plus 4, 12, plus 4, 16, plus 4, 20, plus 4, 24, plus 4, 28, plus 4, 32. Keep adding 4. So this is 4, 8, plus 4, 12, 16 plus 4, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, 64, add 4 here, 68, 72, 76, 80, 84, add 4, 88, after 88, what do you have? 92, 96, up to 100 itself, because they said within the first 100, because 100 is also a multiple of 4. So these are multiples of 4. Now, after mentioning the multiples of 4 up to 100, now let us mention multiples of 6. You start with 6, and then you keep adding 6, 6, 6, until 100 or something less than that. So let us go. 6, we have 12, we have 18, so 6 plus 6, 12, plus 6 here, 24, you have 30, 36, plus 6 here, 42, plus 6, 48, plus 6, you have 54, 60, 66, 72, plus 6, 78, plus 6, 84, plus 6, that will be 90, plus 6, 96, plus 6 will be 102 out of the range. So 102, don't take it. Now, question, at which distances will both buses stop together? Look for common multiples. Common multiples are the numbers which are found in this list here and in this list here. Those are common multiples. Now, can we sort them? Let us try. We have the multiples of 6 and those multiples of 4 which are common. We have 12, 12. We have 24. We have, after 24, we have 36. After 36, we have 48. After 48, we have 60. After 60, we have 72. After 72, we have 84. So you will write common multiples are. So common multiples are. Common multiples of which numbers? The common multiples of 4 and 6. The common multiples of 4 and 6 are The first one was 12. We got 12. 24. 36. 48. 60. 72. 84. Let me cross check. We got 12, 24, we got 12, 24, 36, then we had 48, like this list I have given here, right? Now, the next question. There are two main concepts which confuse lots of people: multiple and a factor. I repeat, multiple and factor. What do we mean by saying a multiple of a number or a factor of a number? Let's take another example. If an integer, say 16, that is an integer. Now, 16 is the first number. Pay attention here. 16, this 16 here. Now, let us say this 16 is getting divided by another number, say 2. Now, 16 divided by 2, you are going to get exact answer with no remainder. 16 divided by 2, what is the answer? Is 8. Now, let me talk about this number, which we call it the first number. And I will talk about this number, which we call it the second number. Now, this first number here, which when you divide by the second number, which is 2, if you get the answer without a remainder, therefore, the first number is known as the multiple, and the second number is known as the factor. I repeat, the first number is known as a multiple. The first number is a multiple. This is the first number. The second number, this number which comes second, the second number is a factor. Okay. Now let's go back. Here comes a question. If an integer is divided, or if an integer divides another integer exactly, meaning without leaving a remainder, therefore, integer is called a multiple. Don't confuse here. I repeat, if an integer divides another integer exactly with no remainder, the first integer is called a multiple. The first integer is a multiple of the second number. Likewise, if an integer divides another integer exactly with no remainder, the second integer is called a factor. So this factor comes here. So, to wind up, if an integer divides another integer exactly with no remainder, the second integer is called a factor. Likewise, if an integer divides another integer exactly with no remainder, the first integer is called a multiple. So, the first number here is a multiple and the second number here is a factor. Next question. A shuttle service carries passengers in batches of 6. I repeat. A shuttle service carries passengers in batches of 6. However, they avoid numbers that are also multiples of 12. They avoid. Since those require bigger buses. So a shuttle service carries passengers in batches of 6. However, they avoid numbers that are also multiples of 12 since they require bigger buses. Find any 3 possible passengers totals they could carry. So what is the concept behind? Listen carefully. The concept for this question. A shuttle service carries passengers in batches of 6. However, they avoid numbers that are also multiples of 12 since those require bigger buses. Find any 3 possible passenger totals they could carry. The concept is, here you need to find numbers that are multiples of 6 but not multiples of 12 and choose any 3 of them. So the concept is, here you need to find numbers. Those numbers that are multiples of 6 but not multiples of 12. And choose any 3 of them. That is the concept. Now, what are multiples of 6? Again, multiples of 6 are. You start with the number 6, and then you keep adding 6, 6, 6, 6, 6, 6, 6 to infinity. So multiples of 6 are 6, 12. So you have 6, 12. Add 6, 18. Add 6, 24. Add 6, 30. Add 6, 36. Add 6 to 36, 42. Add 6, you have 48. Add 6, you have 54. Add 6, you have 60, etc. Because multiples of a number, they go to infinity. That is why the question says find any 3. So let us continue with multiples of 12. Now, multiples of 6 are done, but they go to infinity. Let's go to multiples of 12. Same story. Start with 12. Then keep adding 12, 12, 12 to infinity. So add 12, 24. Add 12, 36. Add 12, 48. Add 12, 60. Add 12, 72. Add 12, 84. We can say, and so on. Now, here, what is the question saying? A shuttle service carries passengers in batches of 6. However, they avoid numbers that are also multiples of 12, since those require bigger buses. So what do? We're going to select only those which are multiples of 6, but they are not multiples of 12. Those numbers are, we have to avoid only multiples of 12. So multiples of 6, the multiples of 6, but they are not multiples of 12 are, the first one is 6. This 12, avoid it, because it is a multiple of 12. We need to avoid that. The next is 18. 24 is a multiple of 12, which we have to avoid. Go to 30. 36 is a multiple of 12. We need to avoid this. Go to 42. 48 is a multiple of 12. We need to avoid that. Then take 54. 60 is a multiple of 12. Avoid that. So you keep going. But they need only 3. They need only 3. So what are they? First, let us put them here, that the required numbers are, we got a 6, we got 18, we got 30, we got 42, we got After 42, we got 54. And we said, and so on. But what do they need? Find any 3. Okay. Choose any 3. And we prefer the first 3. So any 3 numbers are, I can pick 6, 18, 30, or you can pick 18, 30, 42, or you can pick 30, 42, 54, because there is no condition that says find the first 3 possible passengers. They just said find any 3. So I would rather take 6, 18, and 30. Stop here. Okay, so the next question. Ten bus routes leave a station at intervals of 4, 5, 6, 7, 8, 9, 10, 12, 15, 20 minutes. Those are 10 buses, those are 10 bus routes which leave stations at those intervals. One route, which is a 9-minute route, is temporarily suspended for maintenance and must be ignored. If it must be ignored, here comes the question. What is the shortest time? What is the shortest time after which all the remaining buses will leave the station together? Shortest time. Suggest LOCM. So the concept here is this. Here we need to find the smallest number, lowest, something like lowest, the smallest number that is a multiple of all the numbers given except the 9-minute route. So here we need to find the smallest number that is a multiple of all 10 bus routes, of all 10 bus routes. But guess what? Except the 9-minute route. Except the 9-minute route. Except the 9-minute route. That is all. Here we need to find the smallest number that is a multiple. And the smallest number that is a multiple, in other words, is what we call LOCM, lowest common multiple. So we are going to find the LOCM of all these numbers except 9. So now pay attention. What is the method for LOCM? We call it prime factorization. Prime factorization. How does this prime factorization look like? We keep all the numbers 4, 5, 6, 7, 8 Avoid 9, 10, 12, 15, 20. So put all the numbers. What are those numbers? 4, 5, 6, 7, 8, 9. No, 9 should not be there. So 4, 5, 6, 7, 8. So 4, 5, 6, 7, 8. Skip 9. 10, 10, 12, 10, 12, 15, 20. Let me check. 4, 5, 6, 7, 8, 9, skip. 10, 12, 15, 20. Then, once you have kept all the numbers like this, then the smallest possible prime number is 2. So you start with 2 if there is any number that is divisible by 2 in this. So 4 divided by 2, that is 2. 5 divided by 2, not possible, so copy paste 5. 6 divided by 2 is 3. 7 divided by 2, not possible, copy paste 7. 8 divided by 2 is 4. 10 divided by 2, 5. 12 divided by 2, 6. 15 divided by 2, not possible, copy paste 15. 20 divided by 2 is 10. Again, 2. 2 divided by 2, 1. 5 divided by 2, not possible, copy paste 5. 3 divided by 2, 3. 7 by 2, 7. That is 2. This is 5. That is 3. 15 divided by 2, not possible. 10 divided by 2, 5. Can we still go by 2? Yes, why not? 1 divided by 2, just copy 1. 5 here. 3, 7, 1 here. 5, 3, 15, 5. Okay? Can we still go by 2? No, can't go by 2. Can't go by 2, so what do we do by 2? Not so by 3. By 3, 1, 5, 1, 7, 1, 5, 1. 15 divided by 3, 5. Here 5, not possible, so 5. Can it go by 3? No, by 5. So we have 1, 1, 1, 7 here, 1, 1, 1, 1, 1. Can it still go by 5? No, this time by 7. So you have 1, 1, 1, 1, 1, 1, 1, 1, 1. That's all. Now, how do we get the LCM? What did I say? Take these numbers here. Take these numbers here. These numbers, multiply them. That will give you the LCM. So we're going to do 2 into 2 into 2, 2 into 2 into 2, into 3, into 5, into 7. Okay? So you have 2 into 2 into 2. How many 2's? 1, 2, 3. 1, 2, 3 2's, and then 3, 5, and then 7. When you multiply this is your homework, but I'm giving you the answer, is 84. Sorry, is 840. So 840, but what is the question asking for? What is the shortest time? All the timings are given in minutes. So go ahead and saying the shortest somewhere. So shortest time will be after, what is the question here? What is the shortest after which all the remaining buses will leave the station together? So it will be after, let me adjust a few things here. So shortest time will be after. Shortest time will be Shortest time will be after 8:40 minutes. Okay, that's all. So let me see how much time. Okay, let me go for 18 minutes. Okay, shortest time will be that. Okay. Look at the list of primes. Prime means prime numbers. Prime numbers. Now, this table, we discussed it in the classroom, but I told my students that they have to memorize all prime numbers from the smallest possible prime number is 2. So they have to memorize the prime numbers from 2 all the way until 100. So this table, you need to memorize only prime numbers. But for the purpose of this video, I'm going to copy paste all the prime numbers from this table, put them here. But you need to remember all the prime numbers until roughly 100. So for the purpose of this video, I'll copy paste from here, put them here, so that you understand what the concept behind. So prime numbers till 100, the smallest one is 2, next 3, then 5, then 7, then after 7 you go all the way to 13. Sorry, so we have 2, 3, 5, right, let me start afresh. 2, 3, 5, 7, so you have 11, 13, 17, 19, after 19 you have 23, so 23 keep going to 29, 29 keep going to 31, 31 keep going to 37, 37 keep going to 41, 41 keep going to 43, 43 keep going to 47, after 47 keep going to 53, after 53 keep going to 59, after 59 keep going to 61, after 61 keep going to 67, after 67 keep going to 71, after 71 keep going to 73, after 73 keep going to 79, after 79 keep going to 83, after 83 keep going to 89, after 89 keep going to all the way to 97. Now, what is the smallest possible prime number? The smallest possible prime number is 2. What is the largest in this list? The largest is 97. Now let us answer the question. What is the smallest difference between 2 successive primes? The smallest difference between 2 successive primes, you do the difference between these numbers here, 2 and 3, meaning do 3 minus 2. The answer you get will be the smallest difference between 2 successive primes. What is the largest difference? The largest difference is the difference between this 97 and 89. So this gives you these two numbers here will give you the largest difference. The largest difference. These two here will give the smallest difference. These two here will give the smallest difference. Smallest difference. Okay? 2 and 3 gives you smallest difference. 89, 97 give you the largest difference. So here you write smallest difference is 3 minus 2 equals 1. Largest difference is, you take 97, you minus with 89. 97 minus 89. What is this giving you? Just pause this video, work it out. So you have 97, 89, subtract this. 17 minus 9, that is 8. And you have, that is 8, remainder 0. So that will be equal to 8. So the smallest difference is 3 minus 2 equal to 1, and the largest difference is 8. I think that is clear. All right. The next question. How much time do we have? Let me see. Okay. Let us carry on. A class has 28 boys. A class has 28 boys and 36 girls. Now, the teacher wants to find the numbers that can divide both 28 and 36 equally without leaving a remainder. What are the common factors of 28 and 36? What are common factors of 28 and 36? Common factors. Common factors of 28 and 36. We have to mention factors of each number separately. So factors of 28 are, how do we mention factors of any number? Start with 1, because 1 is a factor of any number, and keep the number itself, that is 28. So the factors of 28, the factors of 28 are 1 and 28 itself, and then go to 2 if 28 is divisible by 2. Yes, so 28 divided by 2 is 14. Keep that number there. Then go to 3. 28 divided by 3 is not possible. Go to 4. 28 divided by 4. 28 divided by 4 is possible? Yes, it is 7. Then go to, after 4 is 5. 28 divided by 5, not possible. Go to 6. 28 divided by 6, not possible. Go to 7. 7 is already written here. So you stop. So the factors of 28 are 1, 2, 4, 7, 14, and 28. Factors of 36 are To mention the factors of any number, you start with 1. So 1 and keep the number itself, 36. So the factors of 36 are 1 and the number itself. Then go to 2. If it is divisible by 36, 36 divided by 2 is possible. You write 18. Go to 3. 36 divided by 3 is possible. You have 12. Then you go to 4. 36 divided by 4 is 9. So you write there 9 here. Then you go to 5. 36 divided by 5, not possible. Go to 6. 36 divided by 6 is 6. Go to 7. 36 divided by 7, not possible. Go to 8. 36 divided by 8, is it possible? Find out. Okay. So that is not possible. So 7, 8, no. 9, yes. It is already written here. So the factors of 36. The factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, 36. Now, which one are common? Common factors. Which factors are available here and here? That is 1. That is 2. That is 4. What else? We have 1, 1, 2, 2, 4, 4. Do we have any other? No. So we have 1, 1, 2, 2, 4, 4. I don't see any other. So these are common factors. Common factors of 28 and 36. 1, 2, 4, 1, 2, 4. All right, let me see. Okay. I have like 6 minutes to wind up this. Another question? A farmer has 24 apples, 36 oranges. So we have 24, 36, and 60. He wonders about numbers that can exactly divide the counts of all the 3 fruits. What are the common factors? Same question. Common factors of 24, 36, 60. You can pause this video and try this. But otherwise, let me start quickly. Factors of 24 are, what are they? Factors of 24, 1 and 24. And then you go to 2, that is 12. Go to 3, 24 divided by 3, that is 8. Then go to 4, 24 divided by 4, that is 6. Go to 7, no. After, this is 1, 2, 3, 4, 5, no, 6. Yes, so 24 divided by 6, that's all. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, 24. Go to factors of 36 are. Factors of 36 are, start with 1 and the number itself, 36. So you have 1, go to 2, 36, that is 18. Go to 3, 36 divided by 3, that is 12. Then after 12, so you have 1, 2, 3. 36 divided by 3 is 12. Go to 4, 36 divided by 4, That is 9. Go to 5, no. 6, yes. Because 36 divided by 6 gives you 6. Stop there. Because 6, yes. 7, no. 8, no. 9 is already there. So you have factor of 36 are 1, 2, 3, 4. 1, 2, 3, 4. Then you have 6. You have 9. You have 12, 18, 36. Lastly, factors of 60. Do the same thing, factors of 60. I will go straight forward. 1, 2, 3, 4, 5, 6, then 10, 12, 15, 20, 30, then 60. Okay? Then what are common factors? This is why you need to pay attention. Common factors of all these three numbers. Common factors are, look at all these. 1 is found here, 1 is found here, also here. So you're going to write here 1. Then 2. 2 is here, 2 is here, 2 is there. 2. Then 3. 3 is here, 3 is here, 3 is here. So in all cases, that is what it means by common. Then 4. 4 is here, 4 is here, 4 is here. Then what is? 6. You have 6 here, 6 here, and 6 here. How about 12? Do we have 12? Yes, we have 12 here, 12 here, and we have 12 here. Okay? So these are common factors. And thank you very much for listening to me. Sorry, I have prepared like many videos because I wanted to review all 5 chapters. And those chapters, I've tried to review them using worksheets, which you provided, and also some extra questions from the chapter Prime Time. All right? My name is Mr. Zebron Ernest, maths teacher. So until next time, I wish you all the best in your upcoming exam. Stay safe. Make sure that you watch all the videos and be healthy. All right? Bye-bye. All the best.